In this video, we are going to expand our knowledge of vectors, talking about standard position and vectors in component form. So in the last video, I stressed that that vectors do not live anywhere in space. They only describe two things: magnitude, which is the length, and then direction that the vector is pointing. So we do need to talk about where to maybe put these always to have some kind of standard position. So to have it live somewhere if we need to talk about it. So the standard position of any vector or direct line segment is we put the initial point at the origin. We're going to do this quite a bit. What we're going to do a whole lot of is we're going to talk about like something being maybe pulled by two forces like this, and we're going to have to talk about those. And what we do is we actually put these like in standard position like that, like X, Y. So we're going to be using standard position quite a bit. You don't need to know what I'm talking about exactly there, except for that we're going to have vectors pulling on things, and since they don't have a place to where they exist, live in space, 3 dimensions, 2 dimensions, I can put them at the origin, which is very great to put them at the origin. The reason being is this next form. Okay, so component form. I'm sorry for my different fonts here. I need to get this figured out. The vector form, the component form, describes from standard position my x and my y. So let's take a look at the example that's on the screen here. We'll call this vector v. They used just generic notation. So this point goes from 0, 0, and let's go ahead and call this point what it is, 3, 2. The vector in component form, standard position means it just lives at the origin. The reason we like that is to describe my vector. What we're going to do is we use these angle brackets. We're going to use these a lot. They have to be angled, not rounded. If they're rounded, it looks like a point. This is going to describe the x movement here. Let's just put x, and then y there. So it's like how much they change. Actually, let's do this. Let's be a little more formal here. It's going to be the change in x and the change in y. It's how much it actually changes. So the reason we like to put it in standard form is it starts at 0, 0, and 0 in the x, so let's look at our x's here. The 0 goes from 0 to 3, so the change in x would be 3, right? The change in y would be 2. So how we describe this vector is using this angle brackets, that the vector goes 3 to the right and 2 up. Notice it doesn't say start at 0. I could move this vector anywhere I want on the screen in the Cartesian plane, and it's still going to respect the changes here. It goes 3 to the right and 2 up. It doesn't, this says here, what I boxed off, doesn't say anything about where to start, right? It just tells me how to move. Now with this, if I think about the length of this vector, I can, in standard position, if I draw this triangle, we're kind of talking, I lip service in the last video pretty quickly, but the length of this vector is just the hypotenuse of a triangle. And notice that this is v1 and this is v2. So if I wanted to find the length of v, right, if I wanted, and we got to be careful here, the length means this, right? That's in that last video, the magnitude, and we're about to formally introduce that as I scroll down. So if I wanted to find the length of that thing, I would just find, so the length of the magnitude, this is all written below. It's going to be the Pythagorean theorem, v1 squared plus v2 squared, and then I take the square root to find it. So this is how we find our magnitude. Okay, so definition of component form. We kind of just talked through that pretty quickly. But component form looks like that, where v1 describes the change in x, v2 describes the change in y. Now, for two vectors to be equal, this is where my font gets all janky, I'm sorry. For two vectors to be equal, I have this v here and I have this u here. Literally, it has to be what you think it should be if they're going to be equal. v1 has to equal u1, v2 has to equal u2. That's the only way two vectors are equal. Okay, now let's say they gave us an initial point and a terminal point. And we're going to do an example of this here in a moment. But let's say, hey, they said the vector goes from this point to this point here. Right? How we can find that vector, PQ, is we take terminal minus initial in each component, right? Because remember, component form, this form here, This form here talks about the change of x, comma, change of y. It's describing that. So to find it, I just got to find how much does the x change. So we take q1 minus p1. That's fine. That finds how much x changes. And then q2 minus p2 tells me how much y changes, putting it in component form. Okay, moreover, the distance formula, which we talked about in the last video, and then I showed you to the triangle again above. There's our definition of our magnitude. You're not going to think distance formula. You're not even going to think Pythagorean theorem. All you got to think is I'm going to square each component, add them together, and take the square root. We're going to do this for the whole course. Take the magnitude. We're going to do the magnitude up until second to last section that's planned on getting to. If we have to adjust because of time, we'll do that. But up until that point, we're going to be using magnitude. So it's very important for you to get them in. Okay. Another definition of the magnitude, another name for it, not definition, is the norm. We're not going to see this much in this class, except for we're going to call something a normal, and that'll make something different. But the norm is used in other applications, just not too often in Calc 3, but you may see it in your physics courses. Okay, the length is called the norm, or the magnitude is the word that we're going to use. If the length of a vector is 1, it's called a unit vector, just like back in trig, unit circle, right? This highlighter, unit circle means 1, so it has a length of 1. And then this one is the weird one. If the length is 0, we actually have something called a 0 vector, and we actually write 0 with an arrow of it, and it means 0 in the x, 0 in the y, stationary. We still have it, even though it's kind of silly. We still got to talk about it. Okay, let's do an example to kind of wrap this up all together. They want to find the component form and the length of a vector that has initial point P. That we'll call P and Q. You can label anything you'd like in a problem for me. Just be obvious about it. That is obvious for me. That you named one point P, one point Q. So to find point PQ, I'm going to use the arrow because it's a vector. I said point. My apologies. PQ vector. I got to take x's and subtract them. And then I got to take y's and subtract them. And this is going to end up in having a component form. So -4 in the x. Be careful with this. This is that whole back, remember, in doing slope for the first time, that minus negative stuff trips us up. So that is a 10. So the component form is -4, 10. That means to get from point P to Q, I go -4 in the x direction and 10 in the y direction, and it gets me to point Q. This vector, remember, it doesn't live there. Even though they said this point to that point, I can move this vector anywhere I want. It just describes, right now, it describes a direction, right? So they did want length, okay? Remember, length is magnitude. So I'm going to write that in here. Or norm, whatever you want to call it. I will be calling it magnitude, right? So to find the magnitude, remember, it's our 2 bars. Oh, I want to mention this. You're going to see, I steal from multiple textbooks. I steal from multiple professors. It's just kind of how education works. Some books, let's write a note here, actually, for this, because some of you guys are going to see it. So here's a note. Sorry for my handwriting, some textbooks, textbooks, and professors, let's just be lazy about it, use 1 bar to mean magnitude. The reason I don't like doing it, and they have a valid reason to not care, the reason I do it is because the straight bars remind me of absolute value. But if I think about what absolute value means, it means distance from 0. Absolute value doesn't make sense to use if I'm talking about a vector, right? A vector is this directed line segment that doesn't live anywhere. Doesn't make sense to talk about magnitude. So in context, you should never get this mixed up with absolute value. So I don't like using it because I don't want to confuse you. and get them mixed up. But I do want to give you a warning that you may see a problem that says that, and you just have to read the room, right? PQ is a vector. Okay, it doesn't make sense to take absolute value of a vector. It only makes sense to take the magnitude of a vector. Okay, so let's take our magnitude. So this is going to be the square root of negative 4 squared plus 10 squared. Eventually, I'm cool with you guys not showing that. You can just say the magnitude is what it is. So that is the square root of 116. In Calc 3, I'm happy with that. That doesn't bother me at all. But I know solution manuals, checking your work and stuff, they're going to care. So this is 4 times 29, which is 2 times the square root of 29. I believe I'm doing that in my head. 4 times 25 is 100, and then 4, 4, 6. Yep. Okay, so that should be it. I am great with this. That is fantastic for me. If you want to get really good at your foundational math and your algebra, stuff like that, I recommend matching the answers or trying to match the answers that are in the back of your text, the solutions that you'll be seeing. Match them. Your algebra and everything will get extremely strong.